Priyanshi. Hello students, how you guys are doing? I hope you are doing well. So let me introduce myself Priyanshi Sharma, and today I am going to teach you an important topic, point defects, from the chapter of solid state in chemistry. So let's start. So first of all, we start with the definition of point defects, like what is a point defect. So point defects occur in a crystal when the crystal deviates from ideal crystals because of some missing atoms, displaced atoms, and extra atom. Then this deviation of any crystal from the ideal crystal by the missing of some atoms, displacing of atoms, and presence of some extra atoms in the interstitial sites is called point defect. Now let us start. There are mainly two types of point defects. First is Frenkel defect and second is Schottky defect. In this lesson, we're gonna talk about Frenkel defect. So first, the definition of Frenkel defect. These type of defects arise when an ion occupies interstitial position between the lattice points. So now the question arises, what is an interstitial point or position? So as you can see in the diagram, these empty places between the ions of a lattice is called interstitial positions. And when an ion leaves its original position and comes into these interstitial positions, then this type of defect is called Frenkel defect. Now, the Frenkel defect appear in crystal in which the negative ions are larger than the positive ions. Or basically I mean to say by this statement is that generally क्या हमेशा ही in every scenario the negative ions are greater than the positive ions, but the Frenkel defect occurs in those crystals in which the size difference between the negative ion and the positive ion is very large. Now, in Frenkel defect, the whole crystal remains neutral because the cation didn't leave the lattice, it just go into the interstitial position. As you can see, the cation didn't leave the lattice, it just shifts from its original position and come into the lattice. Now why positive charge ion is only comes into the interstitial position? Because the size of positive ion is lesser than the negative ion. So that's why interstitial positions have small spaces, so only the ion which is smaller in size go into the interstitial position. For example, this type of defect is shown by AGBr, ZNS and AGCl. I hope you understand it well. Thank you. Have a nice day. Thanks for watching. Keep working hard. Stay safe. Bye. Love you.